In today's lesson, we will be doing section 9.4, which is about direct, joint, and inverse variations. Our target is going to be to determine how variables can be related. There are three types of variation. The first one is direct variation. This is the variation between variables that we are most familiar with. In a direct variation situation, y varies directly as x if there is some constant k such that y equals k times x. We should be used to these types of equations because normally what we're used to, k is our slope, k is our m. Okay? When we're using direct variation, we use the k value, which stands for the constant of variation. In an example involving direct variation on how two variables can be related in a direct way, we have this example. If y varies directly as x and y equals 16 when x is 4, find x when y is 20. There's a couple different ways that we can do it. One way involves a proportion. One way involves making the equation, finding the constant of variation. This is how we can make a proportion. If you were to take this equation and solve for k, you would divide x away. So in every direct variation situation, the constant of variation for that situation is found by taking the y value divided by the x value. So when you have a situation where you know y is 16 when x is 4, those variables vary directly. So you can take the y of 16 and divide it by 4. If you want to find x when y is 20, you set up a similar fraction where you know the y value of 20, but you're looking for the x value that follows the same variation or has the same constant of variation. Therefore, we're able to set up this proportion. And when you set up the proportion, you can cross multiply and solve. A second way that you can answer this question is you could set up an equation. Okay, you could set up that 16 equals k times 4, where 16 was your first y value, and 4 was the x value that got you that 16. And then you can solve for k. What you would find is that the constant of variation is 4. So that when you come over here and when you want to find x when y is 20, you set up the equation now where 20 equals your k value times x. Divide both sides by 4, and you find that that other x value is 5. Our second type of variation is known as inverse variation. This is one that we're not quite as familiar with. This is dealing with our rationals. Y varies inversely as x if there is some constant k such that x times y equals k. In this situation, if you wanted to put it into a y equals form, what you would notice is that the x is in the denominator. So this is a rational equation with an asymptote of 0, okay, just as we've discussed in the previous section. When we're using an inverse variation, okay, this is an example using inverse variation. We can also set up a proportion, or we're going to be able to use the equation itself. Okay. If y varies inversely as x and y equals 5 when x is 16, find y when x is 20. This is the proportion we can set up. Okay. Notice that the common x and y value are across from one another on the fraction. Okay. Why is this? Again, because of how this is set up. Because you would have to multiply both sides by x to find the constant of variation. What these proportions are set up to do is so that you are finding the constant of variation in each case. When you multiply the x and y, that's going to find you the constant of variation. When you multiply the other x and y, it should equal the same constant of variation. So when you set up your expression, it says when y is 5, x is 16, that 5 and 16 go on across from one another. When you want to find y when x is 20, that missing y and the 20 go on the other cross from one another. Okay, you can cross multiply and solve and find your missing variable. Another way to do it is to take these values of x and y that you were given and use the equation. X times y equals your k value. What that would tell you is, it would tell you your k value. Your k value in this case is 80. So now in the other scenario, you want to find y when x is 20. Okay, x times y equals the constant of variation of 80. Divide both sides by 20, and y equals 4. So you can set up a proportion, or you can use the equation. The last kind of variation is joint variation. Joint variation is involving three variables. It's more similar to direct variation. Y varies jointly as x and z if there is some number k such that this equation is true. If we wanted to find our constant of variation, we would divide both sides by xz, so the constant of variation is going to equal y over x times z. So that's going to be our proportion that we're going to set up. So we have this example. If y varies jointly as x and z, and y equals 10 when x is 2 and z is 4, find y when x is 4 and z is 3. There's our proportion. Again, notice you're comparing those values. That would find a constant of variation, and comparing the second set of values to equal the same constant of variation. So we have the 10, the 2, and the 4 from the first situation. We have the 4 and the 3, the x and the z from the second situation, finding the other y. Okay. You can simplify, cross multiply, and solve and get your answer. Again, you have the choice of just creating the equation. Y is 10 when x is 2 and z is 4. Okay, and you can find your constant of variation here. Okay, the constant of variation would equal 5/4. Okay. So now when you have your other situation, we want to find y when x is 4 and z is 3. We want to find y. We have our constant of variation when x is 4 and y is 3. Okay, we multiply that across. That's really 5 times 3. Same answer of 15. These are a few different examples. Please give them a try. Pause the video. Please give them a try. I'm going to go over two of these examples. I'm going to go over example 1 and example 3. And we'll save the other two for tomorrow in class. Okay. We're going to find y when x is 15 if y varies inversely as x, and x is 10 when and x equals 10 when y is 12. So we're missing a y there when x is 15. If we're going to set up a proportion, I'm going to put those on an inverse variation proportion. I'm going to put them across from one another. Okay. The other set of numbers that we know x is 10 when y is 12. Those need to go on another cross. It's always x is on the bottom, y is on the top. Okay, we can cross multiply and solve here. We get 15y equals 120. We can divide both sides by 15. Okay. And we get y equals 8. In the other situation, if you wanted to set up an equation, okay, you know y is 10, or y is 12 when x is 10. Okay, you'd have the 10 times 12 equals your k value. That's the inverse variation equation. So you know that 120 equals your k. So then on this situation, you have x is 15. You want to find what y is. So x is 15. You're trying to find y when the constant is 120, and y would be 8. Okay. In the second example, you want to find y when x is 5 and z is 3. It varies jointly. Okay, always looking for what it is. Okay, as x is 3 and z is 2 when y is 18. You set up a proportion. The numbers that you know is that 18 pairs with the 3 and the 2. Okay, and the missing y pairs with the 5 and the 3. Okay, what we can do now is cross multiply solve. We can reduce this one actually first, which would make this a little bit easier. That's really 18 over 6, which is 3 over 1. And then it's y over 15. And that's just making it a little bit easier to go ahead and solve. Okay, and we get 45. And if you choose, you can set up the equation as well. We'll do the other two in class to check your understanding. I want you to try this one on your own. Again, this is using volume formula, which is either a direct, inverse, or joint variation problem. Okay, I want you to read this carefully, solve for it. Okay, you do or may need to look up the equation for volume of a cone. Okay, and we will do this in class again tomorrow.